So, good evening to all of you. We are here to start a session on quantitative ability, in which I'll be teaching you matrices and determinants. It's not matrix and determinant, it's matrices and determinants, plural form, because we will do many more matrices, right? So, why we are doing it, first of all, because it's very important and it's very likely that you will get at least two questions from this particular chapter. It is in your class 12, right? And this is short because the exam which you're taking it for preparing yourself for being a professional in the field of econometrics, economics, or data sciences, in which matrices is one of the things which you're supposed to know, and so is the associated number, which is called determinant. So let's get going. I will teach you in this session through questions, right? So let's do this first question, which is in front of us, in which I'm trying to explain you the very basic concept. What is that basic concept? Is equality in matrices valid? It is valid. Equality in matrices is valid. When it is valid, just see over here. The first thing in matrix which we do, we say that it is an order of 2 cross 2. 2 cross 2 means 2 rows and 2 columns. You see this left hand matrix. And what is this matrix? Matrix, as you know, you have studied, it is nothing but rectangular array of arrangement. This is also 2 cross 2. So equality of matrix is valid only when order of matrix on left hand side and order of matrix on right hand side is same. And also, it is not only the order which is same, corresponding elements are same. So what do we have? We have over here 2a plus b is equal to 8. It is very simple. And similarly, first row, second column element a plus 2b is equal to 4. And 2c plus d. Just look at this. Second row, first column, this is equal to 3. And c plus 2d equal to 3. Now it is simple to solve. If I solve this, 3 and 3, both are equal. So 2 plus c plus d, you can write c plus 2d. It is so simple. So c is equal to d. That is the first thing. And if I put this result, c is equal to d over here, I'll get d equal to 1 as well as c. So wow. Out of this a plus b plus c plus d, I have got the values of d as well as c. Now, how do I get a value of a and b? It is simple. We'll solve this and we'll get b is equal to 0 and a is equal to 4. If these are the values, then of course my answer is 6. And we have to solve our questions in 2 minutes. Can this type of question be there in your examination? Yes. So what is the learning which you have over here is simple. In matrices, equality is valid only when order of matrices is same and corresponding elements are same. Right, Bacho? Let's go to the next question. Next question is, can product of two matrices be equal to 0? If both are non-zero. Why am I asking this question? Because if I have two numbers, let's say two normal numbers, real numbers, a and b is equal to 0, it is only true if a is equal to 0 or b is equal to 0 or both a and b are equal to 0. Please note, that is not the condition over here. You can always have a case when there are two non-zero matrices are multiplied. Just see over here, as you know, in case of multiplication, this is a 2 cross 2 matrix and this is a 2 cross 2 matrix. The result will be what? I'm sure you are knowing. This prefactor ka column number over here, this must be equal to post factor ka column number here. And finally, we will get a matrix AB, which will be of order 2 cross 2, which is row of prefactor and column of post factor, right? So what is this matrix over here? You will have matrix which will have four elements. And what will be those elements? How we do compute it? The first row, first column, multiplication correspondingly and adding the items 0 and 3 is multiplied, minus 1 and 0 is multiplied and added. What will I get? I'll get 0. Similarly, I'll get four zeros over here. And wow, this is nothing but a zero matrix. So what do we have over here? I have, through this question, taught you a little bit about how matrix multiplication is done, and also product of two matrices can be equal to 0. Product of two matrices can be equal to 0 even if both A and B are non-zero matrices. So this is the difference from real numbers. This is for real numbers. In case of matrices, you can have the case where both are non-zero. Is it clear? Right? It is so simple. Now, next question. In next question, again, I will again repeat this multiplication of matrix. That's how it happens. If you have a matrix M cross N, just have an eye on the question and the concept which I am relaying you over here, right? This is NP. Students, if you're there, if you have any doubts, you can always ask me through the chat. Please note this n and n has to be equal. Otherwise, multiplication is not valid. So what is necessary condition? Necessary condition over here, necessary for A into B to exist or to be defined. To be defined. What is that condition? I'm sure all of you know it is simple. Number of columns in prefactor matrix. Prefactor is nothing but which is written first. Number of columns in prefactor matrix, which is over here A, must be equal to number of rows. As I'm writing this theory, you can surely answer the question which is in front of you. Number of rows, number of columns here, number of columns in prefactor matrix is equal to number of rows. So we have x is equal to 2. This is the answer. To just verify it again, to complete the concept, please note matrix AB will be nothing but M cross P. Means this N will be getting out of the window, vanished. You will have M cross P. What is remaining? Rows of prefactor and columns of postfactor. So this Y will be nothing but equal to 1. So this is our first part, first basic concept which are here. Any questions? Gurneet Ahuja is asking what will be the difficulty level of IMB paper. See, Gurneet, this is the first time they are going to have a paper. You cannot, and there's no sample paper. We cannot actually tell you exactly what kind of what level difficulty will be there, but I can do a very good guesswork over here. There are 2 minutes per question, and if you look at your CUET or you look at your IPMAT, in IPMAT there is 30 questions in 40 minutes, MCQ types, right? 30 questions 40 minutes, 30 questions 60 minutes. So I'm sure this will be slightly more tougher, or maybe there could be non-MCQ questions. Non-MCQ and MCQ questions are supposed to be taking slightly more time. So you can have either mixture of non-MCQs and MCQs, or you can have a slightly tougher paper compared to your IPMAT. Have I answered your question correctly, Gunri? Which is if you're a class 12th student, the level of questions will be NCRT exemplar level. It will not be NCRT level, it will be NCRT exemplar level. Okay, chalo, let me now get to the next question, which is here. This is a typical question which all of you encounter. See, there is nothing called exponentiation or power function of a matrix. Then why do they ask this kind of question just to confuse you? Okay, so you have to find a pattern in the elements. Elements are what? Which is inside written in this rectangular arrangement. So first of all, we do a into a, which is known as a square. We'll find out a square. What is the best way to find out this a square? We will write these terms a 0 0, and over here we'll write again a, which is 1, 1 by 2, 0 and 0. Please remember the concept which I have told you. Take row, take column. And it is 2 cross 2 and 2 cross 2. So resultant matrix is also 2 cross 2. What is the resultant matrix? A square. This is also 2 cross 2. Now the first row and first column corresponding elements are getting multiplied. The answer over here is 1. And what will be the first row, second column? Let's do pick the second column. Right values here, it is 0. Let's take the second row and first column. Wow, the value is 1 by 2 and it is 0. So a square is also a. If I take a cube, that will be also this 1 by 2, 0 0. So what it in effect it is telling us, we take any a raised to power n, that will be same as a. Do we have any option which is reflecting a? No. So answer is none of these, right? I will do one more question and then ask you whether you have understood this correctly or not. This is an important question. Please make a note of it, how this question was done, right? Let's take a next question. This deals with the concept of symmetricity in matrices. What do we mean by symmetric matrix? Symmetric matrix क्या है? What is the symmetric, and how do we define it? All of you are knowing it. Yeah, come on. Symmetric matrix, we have A is equal to A transpose. And how do we get transpose? ट्रांसपोज का सिंपल है, if this matrix में you have element aij, this aij element turn into a transpose as ji. What is the meaning of this thing? I'm sure you have studied. Rows will become columns and columns will become rows. That's how we understand. But please also remember in your, in your mind, that A12 will be same as A21. This is an A and this is an A transpose. Let me write A21. A transpose. So from here, just come to this matrix. It is saying it is symmetric. So this 2A is A12, isn't it? Of course it is, first row, second column. This will be equal to A21. A21 is second row, first column. So wow, I have got 2A is equal to -4. So simple. It's only a definition which I am supposed to know clearly. A is equal to -2. And similarly, let's take B. B is what kind of an element? It is second row, third column. So of course it will be equal to third row, second column. So B is equal to this element, because it will get transposed, then also the equality remains. So B is equal to 3. So A plus B is nothing but 1. Minus 2 plus 3 is equal to 1. Now let me come to my students and ask, have you understood? Interchange. Very good, Tanvi. Tanvi is absolutely correct. Tanvi, concept is clear with you? Absolutely. Have you got the question correctly? Confirm back by your chat. Okay, very nice. Now let's take another question. It is about skew symmetric matrix. What is an skew symmetric matrix? Skew symmetric matrix is simple. A transpose is not A, but it is what? Minus A. So what is happening over here? All A11, A22, and A 3, 3. That is principal diagonal elements all are equal to 0. Are they 0 here? No, 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 no. One B is there. So this fellow B will be equal to 0. So first of all, this option and this option is incorrect. So either A plus C will be equal to 5 or A plus C will be equal to minus 5. So let us check. Let us see A is where? A is here. A is which term? A, second row, first column is A. What it will be equal to? It will be nothing but equal to minus A 1 2. So what is that value? Minus A 1 2 is nothing but minus of minus 3, which is equal to 3. So wow, I have got A is equal to 3. Acha ji. Similarly, let us see C. And this is 8. So what do we have here? A, third row, second column is equal to C. It will be equal to minus times because transposing and minus 1 is multiplies. Transpose it. Second row, third column, which is the element 8, which is equal to minus 8. So what is the value of C which we have got? C is equal to minus 8. It is so simple. C is equal to minus 8. A is equal to 3. So which is the answer? B is equal to 0. That is true. A plus C is equal to minus 5. One more thing, which all of you who are attending this session or viewing this session afterwards must remember, that determinant of A transpose is equal to A, right? Why? Because shifting the value from rows to columns to rows, the value of determinant does not get changed. But here it is a very, very important part which I am telling you. For skew symmetric matrix, you can update your notes. For skew symmetric matrix, right? For skew symmetric matrix of odd order, and you will always get order as 3, of order 3. I'm just writing so that you don't get confused by writing odd, etc. Determinant of A will be equal to 0. Why it is? Because A transpose will be equal to minus A. Why? Because this is the property which we have over here. And if it is there, then A transpose as we know, this is equal to A, and minus A will become equal to minus 1 raised to the power 3. We will come to this, and I'm sure 100% sure all of you know that K scalar multiplied by A is nothing but K raised to the power order of matrix. N is what, kids? Order of matrix. थोड़ा डिफिकल्ट हो रहा है क्या? नहीं, उतना डिफिकल्ट नहीं आता है. क्या बात कर रहे हो? K raised to power n and determinant of this one. Here minus 1, from here I have got this part. So just let me come back here. Follow my arrow over here. So I have determinant of A is equal to minus of determinant of A. This is only possible when you have determinant of A is equal to 0. So please underline this concept, box this concept. It can sometimes solve question in a jiffy. For skew symmetric matrix of order 3, determinant of A is equal to 0. Let me ask my students. Gurneet, samajh aaya? Gurneet, Tanvi, have you got this correctly? Please confirm back if you're there in the session. Have you got this correctly? That skew symmetric matrix, if it is of order 3, its determinant is equal to 0. Very nice. Let's go to the next question. What do we have over here? Now we are talking about inverse. So we are shifting now the concept from transpose to inverse. What is an inverse? This I have to remember. A inverse is equal to identity matrix of the same order as A is, and this is equal to A inverse A. So this is my concept of invertible matrices. Not all matrices are invertible. If determinant of A is not equal to 0, right, then only A inverse will exist. Yadi, if A determinant of A is 0, then A inverse will not be existing. So that is how you have to remember. And where A inverse, this determinant of A is equal to 0, we call those matrices as non-invertible or singular matrices. Okay, let us come to this question, which is here. Chalo, आसान है, ये दिया हुआ है. Okay, what should we do? We'll multiply both sides with A inverse. A inverse A square, A inverse A plus A inverse I. Excuse me, my throat is not so good. Uh, Being in Delhi has this good benefit that you most of the time during these times you will get bad throat. But that if each one of us who's in Delhi know this fact. Okay, so this is A inverse is equal to 0. From here, we'll get A inverse is equal to I minus 0. Why? How? We have just put it on the other side. So this is my answer. So this was a simple question. It was just a concept explainer. Will you get this kind of question? Yes. If you get 2 to 3 questions, one of the question will be easy, one of the question will be lengthy, and one of the question will be at a moderate level. Can we get 2 to 3 questions from matrices and determinants? Yes, for sure. So you have to be very, very careful. Please revise it well. 2 questions, my conjecture, my guess is there, will be there in your examination when you will be taking this undergraduate entrance examination for IIM Bangalore. Okay. Now, after this, let us solve this question. Give yourself a moment or so and let us complete this question. So again, the same concept which I have told you, there is no power function. There is no way, you can compute I plus A raised to power 50. There is no concept of binomial theorem, etc., etc., etc. So I plus A square will be nothing but, as we have done, I's identity matrix I plus A. That must be written here, but we have removed it. We have not put it because we know that each one of you are aware of I is an identity matrix. So multiply this I plus A into I into A plus A into I plus A into A. Right. So I into I is I into A is A into A is A, and this is A square. As we know that A square is 0, so we can write this is I plus 2A. Now take a pause. Look at this. The power is 2, and we have got, because of A square being 0, I have got this 2 coming over here. This 2. Okay. So let us check. Let's do one more. One I plus A cube. Let us do that. It is I plus 2A into I plus A. Right. Let's multiply. How come this has come? Oh, come on. I have put this I plus A square value over here. So this will become, let me be a little bit faster. 2A plus A plus 2. Again, this is equal to 0. What do we have? Wow. This is simple. I plus 3A. So what is that we have got? This 3 is getting multiplied with A. So kids, what will be value of I plus A raised to the power 50? That is the question. Simple. It will be I plus 50 into A. Why? 2 is getting multiplied, 3 is getting multiplied here, so 50 will get multiplied here. I plus 50. Right. So what do we have now? I plus A into 50 minus 50A is nothing but equal to I. And wow, determinant of I पूछ रहा है, बताओ. Determinant of I is equal to 1. So this is my answer. Have you understood? Is it clear? I think sort of differentiation of applied maths level will be enough. 100% it will be enough because they are actually getting the students from both applied as well as core level. So differentiation at applied maths level will be surely cool. You don't have to worry. Attend my sessions, which is a 6 or 7 session in differentiation. We'll do those kind of question, which I think will appear in your IB entrance examination. Cannot be just it by pre-multiplying A inverse both sides and get A equal to 0. Uh, A will be equal to A inverse. A will be equal to 0. We could have done that. Very good, excellent. We can also do what you are suggesting. I could have done here from here. A square is equal to 0. I will multiply by A inverse A square. This is equal to 0. A is equal to 0. So I'll put it over here equal to 0 and here equal to 0. So this 0 will go out. Wonderful. We can surely do it like this. Great. Now let's come to the next part. Next part, the concept of this, very good intervention, very good. We could have done it like that also. XA, order is 3. So I have told you a concept that if there is a matrix, it is multiplied with a scalar k, and I have put determinant over here. Of course, the formula is k raised to power n multiplied by a. N is what? Order of matrix. Order of matrix. Very nice. So what do we have here? Answer. It is so simple. Order is 3. So x of a will be equal to x cube. Right, kids? Now I'll do one more question. Then we'll see what do we have from your side. Any other questions? Any other suggestions? Over here, I have a is equal to minus 3 and also order is 3. That n is equal to 3. What do we have to compute? 2 a 80. So let us say 2 a 80. Let us put it like this. I'm giving my type of answer. Please, as who was told me here, as Ivan has told me here. Ivan, let us do this question by other method also. He's saying C72. 72 is the absolutely correct answer. 2 cube will come here, and we have A into 80 here. Why 2 cube? Because we are dealing with order 3 matrix. A into 80 will also be order 3 matrix. This is 8, and we have determinant of A multiplied with determinant of A transpose. As we know that determinant of A transpose is minus 3, and this is minus 3 8. So of course answer is equal to 70. Is it clear? Understood, all of you? Ivan has already answered it. Great show. Other others, is it clear? Others who are inside the session? Sarah, Denjam. Who's this Denjam? Please spell your name. Saurabh Chaudhary says, Yup. So, yup, let's go ahead. Let's solve this question. I'll give you a minute or so. Just do this and tell me the answer. There's no option, so you have to solve it and then complete the answer with me. I'm sorry, I'm having a very bad throat. Excuse me. I'll keep on picking up my nose during the session. Um, Chalo, let me help you. Let us compute a square. 1, 0, 0, 0, 0, 1. Be careful while writing at least first time A. Sometimes miss values and then regret later. And we say that silly mistake has happened. So we have to be careful while taking out data from question to my answer sheet where I'm solving the problem. Now, if I solve this, I'll get what? First row, first column, of course, I'll get 1. First row, second column, I'll get 0. Please keep on checking whether I'm doing it right or not. 0. And then second row and first column, second row and first column is 0. Second row, second column. This is 1. Wow. This is 1. Then second row, third column is 0. Then third row, first column is again 0. Third row, second column, sorry, 0. And this value is equal to 1. Wow. So this is nothing but an identity matrix. So this will help me to solve this question. Now give me the answer. Anyone who would have solved this? 27 minus 73. No, no. Have you got, all of you, are you here who have got this a square is equal to I? If a square is equal to I, this will become a. This will a raised to power 6 will become I. A cube will become a, and ये तो a ही रहेगा, right? So what do we have over here? We have 3a plus I. 3a plus I. So we'll compute this 3a plus I and solve the question. Are you with me? Have you understood? Please confirm. Have you understood till now? Here. So we will write 3a, which is 3, 0, 0. And over here, we'll have 0, 0, 3. Everything will get multiplied with 3 kids. 3, and this is 0. Plus, why am I not directly taking the determinant? Because first I have to come to a singular matrix, then I can find the determinant. And this is 1, 0, 0, 0, 1, 0, 0, 0, 1. And let's solve this. Let's see what we have over here. We have 4, 0, 0. We have 0, 1, and then 3. We have 0, 3, and 0. Now, determinant of this 4, 0, 0. You don't have to rewrite in the actual examination. Since I'm explaining you, I'm rewriting the stuff over here. 0, 3, 0. Correct? Anybody who has got different thing? Sir, we can please explain how you write a raised to power 9 is equal to a. Yes, Tanvi. A raised to the power 9 can be written as a into a raised to the power 8 या a square. ऐसे a square के कितने सारे terms आ जाएंगे? 4 terms. A square I have already got as equal to I. So this will be equal to a into I into I into I, which is nothing but equal to a. If it is clear to a, clear to you, please tell me. Tanvi, is it clear to you? A raised to power 9a. Waiting for your response. Yes. Okay, great. I know there is a little bit of lag. Yes, I have. You've got me correct. This is one because one is added here. 1201. So what is my answer over here? 4 into 1 minus 9, which is equal to minus 32. So let me see who has given the correct answer over here. The correct answer is by Ivan. Ivan is doing pretty well. Very nice. All of you other Tanvi, Saurabh, please confirm whether you have also got. I can see your name in front of me. Tanvi, Saurabh. There was one more person who was there earlier. Denjem. Who's Denjem? Okay. Clear. Very nice. So it took a little bit of more time. ठीक है. Let's come to the next concept. I have around 4-5 minutes more, and I will be completing it over here. Adjoint of A. This is relates to your determinant part. This is nothing but determinant of A raised to the power n minus 1. How does this formula has come? Because A into adjoint A can be written as A multiplied with adjoint A. I'm sure all of you will be knowing it. This is nothing but A multiplied with I. So if I take determinant of this A into adjoint of A, I'll get determinant of A and I. I'm 100% sure now you can relate to this formula. Please tell me what will be the value of this from here. First compute determinant of A. It is surely A cube. So what will be the value of adjoint of A? I'm sure you would have given the answer. I don't have the access to the screen. I'll just check. It is A raised to power 6, which is here. A raised to power 6. This is, so let me just go and check the answer from the kids. A raised to power 9. How does this A raised to the power 9 coming to you? Because n over here is 3. Ivan, A raised to the power 6. Correct. Okay, okay. It is not option A. You wanted to say, okay, right. So let me ask you this. This is a we don't have much time. We have around 8 odd minutes to do wrap up the session. This is a very good question. Let me leave you this question for let's say 30 seconds. Let me see who answers this question. This is a 30-second question. This is a typical uh, uh, application of a concept question. This is not a lengthy question. Let me see who has answered this question. Wow. Saurabh has answered. That answer is C. Saurabh, how is the answer C? Acha, it's the previous question. Sorry. Okay, okay. This is a good question to answer. Anyone? Okay. Chalo, let me explain. What will be adjoint of B? All of us know that this is nothing but B raised to the power 2. भाई 3 है 2 हो जाएगा. But what will be the value of B? इतना लंबा चौड़ा कंप्यूटेशन करते करते रात हो जाएगी. यदि k is equal to मैं 5 देता तो हो ही नहीं पाता. But look at this. This is a B is a what kind of a matrix it is? Skew symmetric matrix. And what is the order of this matrix? Skew symmetric matrix of order 3. Have I told you initially that if you have an odd order and you have a skew symmetric matrix, determinant of B will be equal to what? 0. So this answer is equal to 0. है ना मजेदार क्वेश्चन ये? Wow, Ivan. Very good, Tanvi. Excellent, Saurabh. 0. Very nice. Well done, kids. Very good. Excellent. Excellent. Wow. So, you see, the question has been framed in such a manner that it forces you sometime to, do the computation. Computation was not needed here. K is equal to 4 रखने की जरूरत नहीं थी. I could have put K is equal to 100 also for that matter. Or for that matter, 144 also. Just to confuse you because under root K will become natural number. So you will try to do the question by finding out the determinant, which is not the case. Fine. Uh, let me let me ask you this question. This now completes all the concepts which I have told you and puts into one basket. Slightly difficult because it says adjoint of adjoint of A का determinant, right? जब हमें adjoint of adjoint A का determinant निकालना है, this is a tough concept. I'm sure a few of you might be knowing. If you forget the formula, I'm saying most of us remember the formula, but if somehow or the other we forget, then how do we do it? Okay, right? तो उसको करने के लिए क्या है? Let us say we forget the formula, whatever be the scene. uh, this is looking very complex to us. I have to find out first adjoint of B, which will be nothing but B raised to the power 2. Now B is nothing but adjoint of A. So simple. Why to remember this formula? I have to find of adjoint of B. Adjoint of B, I know adjoint of B will be a three-order matrix, so it is B square. B is equal to adjoint of A, right? So determinant of B will be equal to determinant of adjoint of A. It is so simple. I don't have to remember mug up all those formulas which were there. This is nothing but A ka square. So what will be adjoint of B? Determinant of AK square ka square. So I'll find out what is the value of determinant of A. The determinant of A ka value find out karenge and we will complete this sum. There is one more part here. You can compute determinant of A, that is not important. See, this is 3A. Can anybody tell me what it will be? This will be 3 cube and determinant of A. So this value which is hanging here will be equal to determinant of A raised to the power 4 upon 27 into determinant of A, right? Understood? So this is how we could have, you know, cracked this question, which was seemingly difficult. Understood? Actually, if you find determinant of A, it will be nothing but equal to 6, if I'm not mistaken. 1 into 9 plus 4, which is 13, minus 1 into 3, minus 1 into 3, minus 4, plus 2 into minus 1, minus 3. You will get value which is equal to nothing but 9 plus 4, 1, 14, 14 minus 8, which is equal to 6. If you have 6 here, you will have 6 cube upon 27. So this will be nothing but 2 cube. Answer is equal to 8. So that is my answer. Have you understood? Slightly difficult. So I have taken you all type of questions which could be there. Very simple, moderate, and some question requires a little bit of patience of solving and also clarity of concepts. Tricky questions also. 8. Ivan has solved. Ivan, you're doing pretty well. Very nice. Thank you very much. I will complete my this session over here. Uh, Please, this is the kind of a uh, session plan which we have with you. We will have 45-minute sessions each. I'll teach you next session functions and I will try to cover modulus. Then I'll teach you on 11th of November logarithms, then trigonometry, then stats and probability. That will be a challenge, doing both in 45 minutes. But I'm not teaching you, I'm doing questions with you. That is okay. Then limit, continuity and differentiability, differentiation and integrations. These are, just kind of a sampler for you. If you want to, if you're interested, if you want to join our course, if you want a slightly more detailed version, this is in front of you, right? Please note down, please take a screenshot. uh, we are teaching a lot many students like you, trying to put them in a in their best preparation form, so that they can catch this particular seat in their BSc data sciences and BSc economics, right? So this is how we are ending this session. Any questions, anything which you have, you can actually uh, just tell me, uh, or I will end this session. Is it okay? Anything, Ivan, Saurabh, Tanvi, anything you want to ask, or I would go ahead and end the session. I'm sure you would have got. So what needs to be focus of preparation? In my opinion, you have to, because the way it is designed, I think QA will be one of the most important section. uh, if my conjecture is right, there out of 30 questions, not more than 5 to 10 questions will be of DI. Most questions will be of your QA. So I think arithmetic will be 10th level. They said maths of kids 10th, 11th, and 12th. So if I, being a math teacher, if I say 33%, so max, arithmetic can come as 20% because not entire 10th is arithmetic. So that is how it is. That's how it is. So my logic is weak. What can be done in the remaining time? First of all, you don't have to worry, and secondly, do the questions puzzles. Especially, I don't know whether you still have those Olympiads kind of things going on, where you can do at your 11th, 12th level those puzzles which are there, or you can join any of the courses. That is, of course, there. You can join any of the courses. They will teach you analytical reasoning over there. If not join, if you're having a pre-board, you're there, and you're saying no to coaching. If you're that type, then please for sure join the test series. If you join the test series, take tests, you will know what kind of analytical questions you can get. Will it, you will get a flavor of all those coding, decoding, blood relations, arrangements, scheduling, all those kind of questions, which will help you alphanumeric series, which will help you in your this particular examination. So I got around 150s in my IPM in the mock. So what do you think? Can I handle difficulty of this? Surely, 100%. Don't worry about it. Where are you our student, Saurabh? Which center you are studying in? कौन से center में पढ़ रहे हो? I know Neha. I'm taking a little bit more time. She is the administrator of this particular session. I'll just finish my stream within 2 to 3 minutes. CL Rachi. Okay, okay. I think you can handle it pretty well. Don't worry about it. Don't worry about it. What would be an ideal attempt? What is great about ideal? If you're a science student, by the way, ideal is a situation which can never be achieved, whether it is an ideal efficiency of a thermodynamic cycle, or it is an ideal in a gas law, or ideal anywhere. In my opinion, should not have any ideal attempt. Go to the examination center, see the maximum amount of question which you can do based upon your capability. I have cleared many entrances in my first attempt. I never went with a particular कि इतना तो करूंगा, इतना ideal है. Nothing is ideal. Paper simple आ गया. Do all. नहीं आया. Tough है. जितने हो सके उतने करो. Pick the simpler question and do it. There's no ideal attempt, Ivan. I'm so sorry. Ha, Ivan, that's what I'm telling. You are assuming a particular difficulty level of paper. A particular level of difficulty paper, if you're trying to attempt more, your accuracy might go down. I will prefer always accuracy over number of attempts. So if you're asking me, if there is a paper in which 20 question will give me 100% accuracy, 28 question will give me 60% accuracy, I'll go for 20. But 28 question gives me 90% accuracy, I'll go with 2081. So it is contextual. It's a hypothetical question. In my opinion, it does not happen like this. Most of the time, we find our balance between accuracy and attempts. I will tell you my balance. What I used to do. If I used to do 20 question, I always used to think 3 or 4 question will go wrong anyway. If it is a uh, uh, moderate level aptitude examination, that's how I used to attempt. And sometimes I used to get all 20 corrects also. That's how it is. Okay, so I'll end the stream. I think can I now I can say just good night to all of you. Please come for the function session on Thursday, and all the very very best. Thank you very much. I'll end this session now. Thanks a lot. Thank you. Thank you very much. Bye.